In section 2.4, we are going to continue our discussion of slope. The objectives for this section are, after studying this section, you should be able to find slopes and equations of parallel and perpendicular lines, interpret slope as a rate of change, and find a function's average rate of change. First, let's look at slope and parallel lines. If two non-vertical lines are parallel, then they have the same slope. And what do we mean by parallel? Parallel means that the two lines are the same distance away from each other for every point on the line. If two distinct non-vertical lines have the same slope, then they are parallel. Two distinct vertical lines, both with undefined slopes, are parallel. So we can use this information to find the equation of a line parallel to a given line. For example, write an equation of the line passing through the point -2, 5, and parallel to the line whose equation is y equals 3x minus 1. So the line that we are looking for is parallel to the line that is given. So the line we are looking for will have the same slope as the line that we are given. The slope of the line that we are given is 3. Slope will be the number that you're multiplying times your variable x. So our slope is 3. We are also given a point, so we could call that x sub 1, y sub 1, and that is -2, 5. So now that I have the slope and a point, I can use the point slope form of the line to find the equation of the line. So point slope form is y minus y1 is equal to m times x minus x sub 1. Correct my putting that there. So again, the point slope equation is y minus y sub 1 is equal to m times x minus x sub 1. And now we make our substitutions, 3 for m, and -2 for x sub 1, and 5 for y sub 1. Sorry about that. Had a technical issue here. All right, try this again. All right, so now I'm going to simplify this by removing the parentheses. First, I'm going to write the x minus a minus 2 as x plus 2 minus a minus gives me a plus. Now I'm going to distribute the 3 across. 3 times x is 3x. 3 times 2 is 6. Now I'm going to add 5 to both sides to put this equation in slope-intercept form. 6 plus 5 is 11. So there is the equation of the line that passes through the point -2, 5, and it's parallel to y equals 3x plus 1. And it is parallel because the original equation of the line that I was given, the slope is 3x. The line that I found, its slope is 3. So the slopes are the same for the two equations. They also have different y-intercepts, and that would make them parallel. Same slope, different y-intercepts, two non-vertical lines, two distinct non-vertical lines. Two distinct non-vertical lines that are parallel have the same slope, but they'd have a different y-intercept. What about perpendicular lines? Two lines that intersect at a right angle, 90 degrees, are said to be perpendicular. The relationship between slopes of perpendicular lines is not as obvious as the relationship between parallel lines. This figure shows a line AB, that's the blue line, with a slope of C over D. So the rise from point A to point B is C, and the run from point A to point B is D. So the slope, the rise over the run, is C over D. Now we're going to take that blue line AB and we're going to rotate it 90 degrees. That's what the green arrow is showing. We've taken that line AB and we've rotated it 90 degrees. So now we've got a line we're going to call the points A prime and B prime. And now look what happens to the slope. When we've rotated that figure 90 degrees, the rise and the run of the new line are reversed from the original line, but the new run is now negative. So the rise of the line blue that's in blue, the AB line, the rise becomes the run for the line A prime, B prime, but now it's pointing to the left, so it's negative. The line AB, the run was D. When we rotated it 90 degrees, the run becomes the rise, and it is positive. So the slope of the new line A prime, B prime is D, the rise, over the run, negative C, or negative D over C. The products of the slopes of these two lines, since they are reciprocals, if the slope of the original line is C over D, the slope of the perpendicular line is D over C, those two numbers are reciprocals. They're also opposites of each other in sign. So if we were to multiply those two numbers together, a number times its reciprocal is 1, but we're multiplying a negative times a positive, so we're going to get a negative. So the slopes of perpendicular lines, if we multiply them together, we are going to get -1. So slope and perpendicular lines, if two non-vertical lines are perpendicular, then the product of their slopes is -1. If the product of the slopes of two lines is -1, then the lines are perpendicular. A horizontal line having 0 slope is perpendicular to a vertical line having undefined slope. And you know that's true by just looking at the coordinate plane. The x-axis is horizontal, the y-axis is perpendicular. Those two lines are perpendicular to each other. A vertical line and a horizontal line are perpendicular. Okay, so let's find the slope of any line that's perpendicular to the line whose equation is x plus 3y minus 12. So what we must do to find the slope of a line perpendicular to this line that's given is find the slope of the line that's given. So we're going to put that in slope-intercept form. I'm going to add 12 to both sides. I'm going to subtract x from both sides. I'm going to use the commutative property of addition to rewrite the right-hand side. Now I'm going to divide both sides by 3. And again, if I have the numerator of a fraction being more than one term, being divided by a monomial, one term, I can divide each term in the numerator by that denominator. So this is negative x over 3 plus 12 over 3, negative x over 3 plus 4. And we're going to rewrite that first term in terms of a fraction times x. So we have an understood 1 in front of the x. So we're going to write that as negative 1/3 x plus 4. So that is the equation that we were given. That is the slope-intercept form of that equation. So how do we find the slope of a line that's perpendicular to that line? Well, the slope of the line that we're given times the slope of a line perpendicular is going to equal -1. And we saw from that graph that we had when we rotated a line 90 degrees to get a perpendicular line, what we did with the slope is that we found the reciprocal, we flipped it over, and we changed the sign. So to find the slope of a line perpendicular to this given line, I take the -1/3 and I find the reciprocal. So I take the -1/3 and I flip it over. So I'm going to get -3. But then to find the slope of a line perpendicular, I also have to change the sign. So I flip it over and I change the sign. So the slope of a line perpendicular to this line would be 3. You take the slope of the line that you're given, you find the reciprocal by flipping the fraction over, and then you change the sign. If it's negative, you make it positive. If it's positive, you make it negative. All right, slope as a rate of change. Slope is defined as the ratio of the change in y to a corresponding change in x. It describes how fast y is changing with respect to x. For a linear function, slope may be interpreted as the rate of change of the dependent variable per unit change in the independent variable. The dependent variable, we typically use the variable y to describe the dependent variable, and the independent variable, we typically use x to describe the independent variable. So for example, let's find the rate of change for this example. In 1990, 9 million adult men in the United States lived alone. In 2008, 14.7 million adult men in the United States lived alone. Use this information to find the slope of the linear function. So they're telling us that the function that's describing this situation is a line, it's linear. Use this information to find the slope of a linear function representing adult men living alone in the United States. Express the slope, correct to 2 decimal places, and describe what it represents. Okay, so given our example, we have in 1990, 9 million adult men live alone. I'm going to use that as my first ordered pair. So my independent variable is going to be the year, because the population of adult men living alone is going to depend on what year we are in. So my first ordered pair is going to be 1999. My second ordered pair is going to be 2008, 14.7. Again, my independent variable is going to be the year, and my dependent variable is going to be how many adult men are living alone. The number of adult men living alone depends on what year we're in. So my 2 ordered pairs are going to be 1999 and 2008, 14.7. So now that I have my 2 ordered pairs, I can find the slope. So the slope is the change in y over the change in x. And we've been using a formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And we've just been arbitrarily assigning our points to one of these, x sub 1, y sub 1, or x sub 2, y sub 2. So we can call this x1 and this y1, and this x2 and y2. So we have 14.7 minus 9 over 2008 minus 1990. So I'm going to take out my handy dandy calculator, and I'm going to calculate this using my calculator. And as you recall, you have on your calculator alpha, y equals, and number 1 is your fraction. So you can actually do this on your calculator if you want to. And I get approximately 0.32. Okay, so what's this mean? All right, so our change in y, we were representing, or excuse me, the change in y represents the change in the number of men living alone in millions. So this is millions per year. So the rate of change, since the numerator, the change in y represents the millions of men who are living alone, and the denominator was the change in x, which is in the change in the number of years, then our slope represents millions per year. So what does this mean? That in this linear function, the number of men living alone is increasing each year by 0.32 million. So if in 1990, there were 9 million adult men living alone, in 1991, there would be 9.32 million men living alone. In 1992, it would be 9.64 million. So every year, 0.32 million more men are living alone. Now, this function's probably not linear. So what do we do if we have a function that's not linear, but we want to find the rate of change? We're going to look then at the average rate of change. If the graph of a function is not a straight line, the average rate of change between any 2 points is the slope of the line containing those 2 points. We call this line the secant line. So if we have a graph like this one down here representing the heights of a young man, it's not linear. However, we could find the average rate of change of his height between any 2 points. So we could pick 2 points. In this case, we picked the point 1357. So when this young man was 13 years old, he was 57 inches tall. And then we could pick another point, 1876, which means that when this young man was 18 years old, he was 76 inches tall. We could connect those 2 points by a line. We only need 2 points to create a line in the coordinate plane. We connect those 2 points, and the line that connects those 2 points is called a secant line. And we can find the slope of the secant line. And if we find the slope of the secant line, it gives us the average rate of change between those 2 values. So 2 points on the graph are labeled 1357 and 1876. At age 13, he was 57 inches tall. At age 18, he was 76 inches tall. The man's average growth between ages 13 and 18 is the slope of the secant line that connects those 2 points. We calculate the slope by the change in y over the change in x. So we take the difference in the y values divided by the difference in the x values, and we end up with 3 3 4/5. And this is actually inches per year, if you want to know what the units are, because the numerator is inches tall and the denominator is year. So what does this mean, this 3 4/5 inches per year? It doesn't mean that exactly every year this young man grew 3 4/5 inches. It means on average, between the year when he was 13 and the age of 18, between the ages of 13 and 18, on average, he grew 3 4/5 inches per year. Obviously, from the graph, some years he grew more than 3 4/5 inches, and in other years he grew less than 3 4/5 inches. So, but on average, from the ages of 13 to 18, he grew 3 4/5 inch per year. So it's an average rate of change, not an exact rate of change. So the average rate of change of a function, let's say we have 2 points on the graph of our function, and this does not necessarily need to be a linear function. As you can see from our graph here on this slide, this is definitely not a linear function, but I can pick 2 points on this curve. I can pick some point x sub 1 and f of x sub 1. That means that my input is x sub 1 and my output is the function evaluated at that input. So remember, f of x1 and y sub 1 mean the same thing. I could pick another point on the graph of this function, some x sub 2 and f of x sub 2. Again, what's f of x sub 2? It's the output of my function given my input is x sub 2. And I can find the slope of the secant line that connects those 2 points. And I do that by finding the change in y over the change in x. But now we're writing the change in y in function notation because we're studying functions and we need to be using function notations to show that this is a function. So the average rate of change of the function f from x sub 1 to x sub 2 is given by f of x sub 2 minus f of x sub 1 divided by x sub 2 minus x sub 1. This is the change in our output, which we normally call y. We're going to call this now, instead of y, we're going to use function notation, over the change in our input. Change of output over change in input would give us the average rate of change between 2 points on a curve that is a function. Okay, so here is our formula for the average rate of change between 2 points on the graph of a function. Let x sub 1 f of x sub 1 and x sub 2 f of x sub 2 be distinct points on the graph of a function f. The average rate of change of f from x sub 1 to x sub 2 is f of x sub 1 minus f of x sub, I think I said that wrong, f of x sub 2 minus f of x sub 1 divided by x sub 2 minus x sub 1. And sometimes you'll see us write this as delta y. That is the Greek letter delta. When we use a delta in mathematics, it means the change over the change in x. So delta y over delta x. Sometimes we write it that way. So the change in y over the change in x is the change in the value of the function, the output, over the change in the input. So how do we calculate this then? Find the average rate of change for the function f of x equals x to the third from x sub 1 equals negative 2 to x sub 1 equals x sub 2 equals 0. So we're going to find the average rate of change from negative 2 to 0. Now, we could graph this on our calculators if we wanted to, and it looks something like this. Let's see if I can draw this. Looks something like this. And so what we're wanting to find is the slope of the line that connects x equals -2 to x equals 0. So there's x equals 0. That would be x is equal to -2. And we want to find the slope of the line that connects those 2 points, the slope of the secant line. So what we need to find is what are the 2 y values for those 2 x values. So to find the y values, we need to find f of x2 and f of x1, and that'll give us the outputs for the given inputs. So we need to find f of 0, which would be, what's our function? X to the third, 0 to the third, which is 0. So f of x2 is 0 when x sub 2 is 0. Okay, f of x1 would be the function evaluated at -2. -2 cubed is -8. 2 times 2 times 2 is 8. A negative raised to an odd power will be negative. So now we're going to find f of x2 minus f of x1, and we're going to divide that by x sub 2 minus x sub 1. So we're going to make the appropriate substitutions. We have 0 minus a minus 8 over 0 minus a minus 2. So we have 8 over 2, which is 4. So the slope of the secant line connecting the 2 points where x is -2 and x is 0 on the function f of x equals x to the third is 4. So the slope of the line connecting those 2 points on the graph of this function is 4. And that is the end of section 2.4.